You're watching the New Stack Makers, a podcast for people who develop, deploy, and manage at-scale software. For more information and articles about at-scale technologies, please visit thenewstack.io. Now enjoy the show. Well, several years ago, I was working on this story, and there was talk of a possible fork in the community. There was the talk of a Docker fork. And I found Bob. I can't remember how I found Bob. And Bob helped me out a lot. And that's Bob Wise. He's the CEO now of Heroku, which was acquired by Salesforce several years ago, but now, as I understand, is its own division. And Bob, that's an interesting time. And I think it leads into our story about Heroku today. And you mentioned this in the keynote you did at KubeCon Paris. But here's how, I think of it. Because I've talked to several people since then, like Phil Estes, for instance, right?
Oh, sure.
From IBM, right? Or from IBM back in the day. Now he's at AWS, right?
Phil. So I actually worked with Phil at AWS when I was running the EKS team. And
right.
Phil's awesome.
Yeah, Phil's a real, open technology guy. And so this fallout happened, right? A lot of factors, became part of it. I think part of it was Google was just trying to find their own way as a cloud provider. Docker was this young company and they were just clinging on for dear life. But there was this massive community building, right? And, realistically, there was no way that Docker was going to fork, right? Because there was no alternative to it, right? But there needed to be something that would actually be able to be a somewhat resemblance to Docker. And that really was the beginning of OCI. And OCI, and what is the acronym for OCI, Bob? What is it again?
Open Container Initiative?
Open Container Initiative, yeah. And I talked with Phil Estes about this later, and because he kind of helped put the parties together, and that became kind of a core story for not only the overall community, because you see all kinds of organizations using OCI right now, or all kinds of developers using OCI, but it became kind of interesting for Heroku too. So maybe you could tell us about that take on that time and how it plays into kind of a little bit where we are today.
Yeah, I think I was one of the people advocating that we needed to consider a fork. I think that's what got the attention.
Yeah.
And I was working for Samsung at the time.
Yeah.
And the reason that we were so concerned at Samsung about this was this sort of inherent conflict that had sort of built, which was Kubernetes was getting all this popularity, but it wasn't just lots of people talking about it. There were folks like Samsung and many others who were starting to use it at real scale. And we were starting to bet our businesses, really big businesses, on it. And so our concerns were really becoming about stability. We have to have stability, the stability, security, which are, somewhat related in terms of a maturity thing.
Yeah.
And Docker, as you said, was this new startup, obviously under pressure to grow and go fast. And so you had this kind of conflict emerging of one player that just wanted to go fast and innovate really fast, and a bunch of other folks who were oh no, it's time for us to be boring. We really need, and not we're making big bets here, we need to be boring. And so the fork talk was really, I think, about that kind of inherent conflict, and probably inevitable given a thing goes from, let's say, popular among the developers to making big bets by big enterprises. You were, of course, going to have that. And, so I think OCI was a really healthy outcome as a result of that. There were, of course, other container things. I think Solomon talked about this as well at KubeCon about sort of looking at the past. There were other containerized approaches going on. All the way back into the Solaris days that were after the same thing. And indeed, Heroku was one of those. The Heroku approach to this was this thing called slugs, but essentially it was let's call it a proprietary version of the containerized things that were going on in Docker and with Kubernetes. And over time here, the story has converged because Pivotal and Heroku worked together, and some other parties as well worked together on this thing called cloud native buildpacks, which was really kind of how do we take all of the cool things that we had done in the proprietary build system for Heroku, the proprietary build and containerization, and how do we kind of take that innovation and bring it into the OCI containerized world. And in fact, cloud native build packs are now used in things like Knative. So we've really seen this kind of interesting convergence of sort of these innovations into some common standards. And definitely OCI was, I think, a really critical moment in the industry where we were able to make that tip from cool tech to real business.
And OCI serves as really the core technology behind the build pack. Is that right? Or as one of the core technologies?
I think of OCI as really the specification, and there's multiple ways you can get to it. The build, like as long as you build the container, as long as the thing that you come up with works right and follows the standard, how you get there is up to you.
Sure.
And with cloud native build packs, another sort of interesting thing here, like the cloud native build packs, the build packs in general have been really championed and used by folks like Heroku who are running really, really large systems. So you can imagine we're containerizing like huge volumes of applications, containerizing and deploying them. And I think we built a system to do that, but in more modern times, the ability to use like a Docker file and build lots and lots of containers at scale gets to be some challenges. So for example, one of the main things that can happen is, let's say you have some kind of like CVE at maybe the OS level or something, and you need to rebuild a large number of containers. One of the things that you can do with cloud native build packs is you can really, really quickly rebase all of those things, as opposed to with a Docker file kind of setup. You're going to spend a lot of time just rebuilding one container after another. So there's a lot of like caching and optimization that takes place. And so if you're a big provider, like Heroku, or running a big footprint like Cloud Foundry, the advantages of moving to this, let's say, more scalable kind of container build approach has a lot of advantages to it.
So, but a lot of people use Docker, and it's so popular. So,
right?
How do you how do you balance that?
Well, I think it's what's the right tool for the job. And right. I mean, I'm sure there are people who use cloud native build packs, like folks on my team who are like Terrence Lee, who's one of the maintainers there. I'm sure use cloud native build packs for all the stuff they do. But if you're just doing some stuff on your desktop, you're doing small scale things, then the standard Docker file approach probably works great. And Docker has always had a lot of attention to that kind of developer experience. But it's a little bit of that same kind of thing that happens when you start looking at things at scale, and you're at Heroku scale, or even bigger Salesforce scale, or any like really big enterprise that's starting to deal with not just hundreds of images, thousands of images, millions of images that all need to be like maintained and patched and like built really efficiently. Then you end up going to a more industrial grade kind of system. Now, for us, we include that sort of industrial grade system inside Heroku, so a Heroku user just gets to use it, and that doesn't have to build it. But this is why there's been so much interest in cloud native build packs. We contributed it to the CNCF, and there's a lot of different developers that are involved and interested in it. But the theme there of the sorts of folks that are building and using it are the folks that are working at larger scale.
Well, how's it different than build packs? Build packs came first. How do they differ?
So build packs was essentially I was mentioning earlier that Heroku had a proprietary container thing which we call slugs. So right. Build packs was sort of the proprietary version that is used to build slugs. The cloud native build packs is essentially the open version that's built around OCI and building building Docker images in effect. So you can sort of think of it as the evolution of Heroku and some of these pieces towards kind of open standards and cloud native generally. And I was talking at KubeCon as well about we've made a big bet on replatforming Heroku onto Kubernetes. And so, of course, like there's a bunch of pieces to that. And one of those pieces is cloud native buildpacks.
Yeah, because I've been thinking of like this theme on the new Heroku. And I mean, I remember, covering the platform as a service space back in the mid 2000s. It's 2008, 2009, 2010. Cloud Foundry emerged. Heroku, was the darling really of the community. Docker, came out of a platform as a service that Solomon had started. And that really facilitated a lot of new development, and putting the developer first. And then Heroku kind of went inside Salesforce. Where's it been? What happened to Heroku back then?
So I think one of the things that's happened with Heroku is it's grown and grown and grown. I don't think we've done a very good job of talking about that. I think a lot of people think of Heroku as kind of what it was back when Salesforce acquired it, which was this thing that smaller developers and hackers and students really love to use, which was certainly true. But in the sort of subsequent years, we did things like introduce database services, Postgres and Kafka and CI and CD services, a package of stuff we call flow. So, sort of in the intervening time, there was a lot of development that happened to sort of complete the platform picture, and business has grown. But at the same time, I think Salesforce is largely a SaaS. Is a SaaS, right? Like it's a SaaS company. And we had Heroku, which was this PaaS thing, which there's a lot of overlap, especially if you think about Salesforce developers who want to build an application, really want to do it easily. They're not very, they're not religious about platform engineering and what they use and how they use it. They just want to build some code around their CRM systems, their CRM applications. And so Heroku is a really awesome fit for those customers, and we've done a lot of business there, including things like we have a part of our product will synchronize your Salesforce data into a Heroku Postgres database, so you can, if you want to use the Salesforce APIs, work that way. That's great. That's awesome. Most of our customers do that, but if you really want to use a Postgres-based approach, then we synchronize bidirectionally all that, and you can kind of use Postgres as your API, if you will. And so there have been, and that's one of our very popular products. So there has been a lot that the kind of interface between Salesforce, so the overlap between Salesforce and Heroku, that we've delivered. But meanwhile, let's call it the main PaaS business for Heroku has also continued to grow. But we were also seeing that we felt like we could do more here, and so one of the things that we did was we reconstituted Heroku as a proper business unit earlier this year, and we really felt like that would let us focus on the needs of these customers even more. So that was sort of the subsequent to that was really where you started hearing about us. Do the rebase onto Kubernetes and join the CNCF. And that's because we're really trying to expand, like we've done very well in that Salesforce platform overlap, that place where customers need those two things. But we really, really want to expand our business even further with the folks that need a platform. And it seems like from the last KubeCon that there are a lot more people who want all of the advantages of cloud native and cloud native approaches, but they don't have the kind of sophisticated platform engineering teams that you've seen kind of emerge from the front runners in the Kubernetes space. So we're feeling pretty optimistic that there's a lot of folks out there who really need a platform all put together for them, as opposed to having to go build it themselves using the elements like Kubernetes and Prometheus and all the things, right?
Okay, I want to get back to that, but I want
Sure.
to like get your, take on what does it mean to rebase,
Yes.
and, you know, and maybe then help people who are not so familiar with Heroku talk about the philosophy behind your rebase, which I think will, help exemplify, what Heroku is all about.
Great. Yeah, I can do that. So really sort of the same theme. I was saying, we had this uh, proprietary
Yeah,
container
right.
thing, which, slugs and so forth. Well, Heroku was built before Kubernetes was a thing, but
Yeah.
it essentially does a lot of the same things that Kubernetes does underneath the covers. It's a container orchestration system. You have some code, you need to take that code, you need to do a build, you need to turn it into a container, you need to test it, you need to deploy it. If the machine that the container is running on tips over, you need to restart it. You need to be able to do things like horizontal scalability, where, okay, I take that thing, but I want to copy it a bunch of times so that I can, do load balancing across them. Like all of these things that Kubernetes has evolved to do are all things that Heroku has had in the platform for quite some time. So I guess the question is, why move? Like, if you've got all of that, and I think this is really an essential business strategy question, and it's really about what does Heroku do for customers that is really important that they're willing to pay us for, and it isn't really, in our view, the fact that we can like run a database for them or um, run a container orchestration system underneath the covers. It's really, do we pull all those pieces together into a really beautiful user experience with fantastic documentation and all of the essential elements all tied together, database, messaging, pipelines, all of those things. Like the value that we provide is the beautiful integration of all these things, not doing the low level thing underneath. So that's one thing. But then the other thing is Kubernetes velocity is amazing. Like the rate at which Kubernetes has evolved to do new and interesting things faster and faster and faster. And so for a team like the Heroku team, we're looking at, well, for us to be competitive in like that orchestration feature space, speed and scalability and all these things. If we're going to really compete in this space, do we want to try to build all the same things the Kubernetes world is building, just building them ourselves? So this is a classic proprietary technology versus open source velocity thing. And I think we've seen a lot of systems who have there's been a lot of convergence on Kubernetes because it's great and it has awesome velocity and it was really built for these kinds of use cases, and it's gotten hardened and mature. And so we decided that the best thing for us strategically was to use Kubernetes. Let's call it underneath the covers, but essentially to replace a lot of the code that we have been using to do the same thing. And so, of course, like that's a big migration effort for us. There's a lot of expertise that need to be built. We're a long ways down that road now, so that stuff will be hitting production later this year. But it's definitely been an interesting voyage. But we felt like it was a strategic necessity for us to really converge on the industry standard.
What is it required to rebase?
Well, I say rebase, but a lot of it is really rebuild.
Oh,
We built a lot of new stuff. We built a lot of Heroku things kind of like new. And in some cases we're really like, in a lot of cases throwing code away in the long run. Like we still, of course, are going to run our current system and the new Kubernetes based system in parallel for a long time. But if you look at things like, the code, like we have equivalents of the code that we have these things called dynos. And dynos are essentially, like dynos is probably closest in the Kubernetes world to a pod. Or maybe to a deploy. It's not exactly quite analogous, but it's very close. And so, in the old world, we have all this code that like builds the dyno and deploys it and runs it. In the new world, that's 100% Kubernetes code. So the sort of surface area of the code that we're building is changed entirely. And for us, that means that, over time, the folks that we had building all of those kinds of features that Kubernetes provides for us, we're going to put them to work on other things that are more along the lines of continuing to enhance that overall, fantastic user experience.
So how did you build in platform engineering into a Kubernetes environment then?
Well, I mean, the Heroku team is a platform engineering team. That is what we do. That is pretty.
But you were saying earlier you make it more platform. It's a platform essentially, right?
Yeah. So the goal is, I mean, I guess there's two kinds of users for systems like Heroku, and one of them is folks that don't have a platform engineering team at all. And I've certainly talked with a number of customers who have said exactly that, which is one of the things we love about Heroku is I don't have to have a platform engineering team. And that will be true for some customers. For other customers, they will view Heroku as a thing that their platform engineering team also does a buy instead of build. And they'll have other things that they want to combine along with Heroku. And so the platform engineering team just gets to spend more time on building their user experience as opposed to doing all that work themselves. But the Heroku team itself is fundamentally a platform engineering team.
Yeah, that makes sense. When you're thinking of when you thought about building out for Kubernetes, what are some of the things you had to build brand new then?
I mean, most of the brand new stuff that we have to build is really around kind of creating that Heroku-like experience on top of Kubernetes. So that's all kind of the new bits. There's definitely areas, for example, again, like this is a thing that happens when you're running at the huge scale that Heroku runs at, which is we have to be really careful about cost to serve. And so we spend a lot of effort on kind of tweaking and tuning things to make sure that we're running them really, really efficiently. And so, in that regard, we're similar to, any of the other cloud providers in terms of how much effort we put into that kind of attention to detail in our cost management. So we've had to do, some work there for sure.
There's this discussion that we've had over the years about opinionated architectures, right?
Yes.
Cloud Foundry is very opinionated.
Yes.
Right? How would you characterize Heroku and with this new rebase or this new replatform?
We're still very much in that opinionated camp, for sure. Like I think that it is. I'll say it's almost impossible to create a really beautiful, integrated, easy to use, well documented kind of platform without going in the opinionated direction. You have to reduce the number of choices. You have to do fewer things, and you have to do them really well. So yeah, I mean that's what we do. You can sort of think of our new Kubernetes rebase as being the Heroku opinion as to how you should run on Kubernetes. It's got Kubernetes underneath, but a lot of the things that we do in terms of bringing the CI tools, CD tools, and so forth is new. One thing that we are doing with that though is we're supporting some additional standards like OTel. Like we're doing a big push on OTel because some customers, especially those with platform engineering teams who have big like observability infrastructures, they would really want to take systems like Heroku and kind of plug them into their existing management frameworks. So there's some like changes and approaches that we've made at that level, but opinionation really matters. And look, if you're a platform engineering team and your platform engineering team has a lot of opinions about exactly the way things should be built, then Heroku or Cloud Foundry is not going to be, or systems of that sort are probably not going to be a great fit. You're going to go and pick Kubernetes and pick all of the, from the constellation of, I don't know, like how many projects are on the latest CNCF, like, the industry roadmap, but I think it's over 200 at this point. So you're going to have to go through and make all of those choices yourself and assemble that. And so, it's really hard. It's very hard to serve both masters, like provide ultimate openness and modularity and do everything you want, and also be opinionated at the same time. So we were definitely in the opinionated bucket. There's no doubt.
So how would you use Heroku with AWS or Azure,
Right.
or Google Cloud?
So today, Heroku runs entirely on top of AWS. We don't run
Okay.
our own data centers. So really, you can sort of think of Heroku as being also an opinionated way to run on top of AWS.
Okay.
But it's also like it's really pretty rare. I mean, maybe that some smaller companies that are
Yeah.
small customers might use just Heroku, but most Heroku customers, especially the big ones, use Heroku for a bunch of the platform things. But then there'll be a thing that they also need to use. I don't know. They want to use a Neptune database, or pick something that they want to use, and so they're going to use the AWS service for kind of all the special stuff, and then they're going to use Heroku as their main platform. And so we run very well in the AWS environment. So we consider it that way. We don't run today on Azure GCP, but customers will do that too. It's a little bit. It feels to the customer like if you were going to run a thing on AWS and GCP, it's going to go across the internet. You're going to use the service APIs. You can certainly do it. We don't help. We neither help nor hinder customers who want to run in a full-blown multi-cloud environment.
Well, that makes, and I can understand that, big customers are running on AWS. Why would they want to do anything else? They're, that's where they are. And I could also understand, like, a lot of organizations don't necessarily want to have giant platform engineering teams, so they can minimize that cost. That could be helpful. I guess the kind of questions I have are like, before I ask you what's next with Heroku is, how are you improving performance, for example? I'm reading up a little bit, performance is always paramount for these larger companies who are building out at scale. What is your, and how do you answer to people who are, trying to get better performance?
Right. So I think there's probably two different types of performance you're asking there. One is just maximum performance, and the other is price performance. And we've been doing work in both. One of the things that we've gotten a lot of customer feedback, and you can see if you went back and looked at stuff we've been shipping for the last couple of years, it's been, hey, we really want to run bigger things on Heroku. And so one of the things we've done is we've introduced larger and larger databases and larger dyno sizes, essentially tracking a lot of what AWS does in this space. Like oftentimes customers have not engineered a thing for horizontal scalability. And it's just cheaper and easier for them to just run on bigger and bigger and bigger things. And as their business grows, that's the easiest way. And so we've been keeping pace with that and shipping a bunch of things. But there's also the price performance as well. And the big bet that we've made here in the upcoming with our new Kubernetes rebase, which so I don't know if you know this, but Heroku does kind of the Android thing. Android has the platform versions that they name after various desserts. Heroku, we have platform versions and we name them after trees. And so the Kubernetes based platform is called Fir.
Okay.
A good Northwest.
Yeah. I approve.
At any rate, so with Fir, we've made a big bet on Graviton, which is the ARM-based architecture out of AWS, and we're seeing really tremendous price performance improvements there with that. And one of the kind of magical things about Heroku is because typically what you do is you just connect to a GitHub repo. So we take the code and we do all the builds and deployments and everything. And so it's pretty easy and straightforward for us to just actually do the ARM builds. Like the customer doesn't have to actually worry about multi-architectures. Now we were running on Intel, now we're running on ARM, doing binary compatibility. They don't have to worry about all those things because we're the ones that take the code and deploy it. We kind of make that happen automatically for them. So we're really excited about the new Graviton ARM-based Fir platform coming up. Also, and this sort of goes back to the same thing I was telling you about, like strategically for us. We want to make sure that we're concentrating on where do we add value and making sure that our team is spending our time on adding value. So we're moving away from building our own orchestration system to using Kubernetes. we have for many years run one of the largest database fleets in the world. Our Postgres fleet is massive.
Yeah.
And last year, we also decided that we were going to migrate away from running that ourselves and move to using Aurora. Aurora is the Postgres compatible database technology from AWS. And so that's available now. So we are sort of moving in that direction as well. And one of the things we get out of Aurora is because Aurora is also is a cluster-based system, it's going to give us even more scalability for some of these really big deployments. So you can run in a full cluster of machines as opposed to running on one big machine, which really helps in those vertical scaling cases.
Why did you move to Aurora?
Well, I mean, that's why we were deciding, like, does it make sense for us to continue to build and operate this massive control plane of systems that runs Postgres instances for customers? And we decided that it probably made more sense for us to use a service underneath the covers. Again, it's just the database analog to us using Kubernetes under the covers instead. So, I think the kind of like strategy shift here you've seen from Heroku isn't just Kubernetes, but you can see like we really are trying to focus all of our energies on where we can be opinionated and provide that beautiful experience and, provide an awesome experience to customers along that way, as opposed to running a lot of the underlying bits, which we think other people can do better than us.
We've seen a surge in popularity for Postgres. Are you seeing that?
Oh, absolutely. And I think this has been a really interesting thing just generally in the industry. Like Postgres really emerged as the kind of core standardized database technology. And so I guess we made a good choice a long time ago in using Postgres with Heroku. But even things like one of the impacts of all of the recent surge in generative AI is a lot of interest in approaches like RAG, which requires vector database support. And although a lot of vector databases have kind of emerged, specialized vector databases, the Postgres community has this thing called PG Vector. We launched support for it, a while ago. And so, it's been very interesting to see, even in these more specialized cases that you would think might lead to a lot of kind of additional databases, which it has. The Postgres community has been pretty amazing at responding and kind of building extensions and other things on Postgres that have kind of kept it in the forefront of being the standard.
On that note, then, about RAG and vector databases, what's your take on those capabilities now for people who are using Heroku?
Well, PG Vector support was, sort of turned into one of our big customer asks, and so that was a thing that we shipped a while ago. But sort of at the early phases of all of the craziness, all of the generative AI craziness. So that's been good. I think we don't presently have a plan to introduce any kind of like new vector database support. Our current plan is to kind of stick with Postgres.
It's pretty good as it is, right?
It's pretty good. It's pretty good for us. And again, I think, look, if you're one of the small number of really big companies that are spending a fortune on training, foundation models in a big way, you're going to do a bunch of specialized things. And really for the Heroku user base, for most customers, sticking with like the well-proven standards is probably going to work best for them. And Postgres is definitely it in this space.
Right. So I guess my last question is, there is a lot of talk about AI and most of it's generative AI, but there's so much more like interesting, technologies that are emerging for infrastructure software, right?
Right.
And I'm just wondering like how you think about those developments and what is it that's interesting to you?
I think it is definitely the case that, and I've seen this a bunch of times, where generative AI has created all this interest in AI approaches. And in fact, this happened to me this week. I was talking to someone and they were describing all the AI stuff they were working at, and I'm listening to it and they're getting a ton of interest in it. But when I poked deeper, it wasn't generative. It was actually, it was like more classic AI approaches, but they were still doing some amazing things with it. So the generative thing has definitely taken a lot of oxygen away from things that are actually pretty valuable. I think we'll see all of that kind of normalize. Here over the next couple of years. I think we're pretty impressed by the capability of a lot of the code gen tools.
Okay.
That's I think in these areas, I mean, you can sort of think about like a programming language is like a very restricted, like much less ambiguous, form than natural language, and the generative AIs are really all these systems are super good at it, super good at generating code. But what we're also seeing is that the effect of having all of that amazing code generation done is a little bit like adding an infinite number of interns to your development team. And it turns out, and by the way, this is one of the reasons why Kubernetes was successful. One of the reasons why Kubernetes was successful is that developer experience was not really the thing. It was really about operator experience, because most teams, most companies spend 90% of their effort and time on day two things, on patching and maintenance and troubleshooting and all of the things, as opposed to the development piece. So if it's a 90-10 kind of split, even if you increase productivity on just like the core development piece, your total throughput doesn't change by that much. Kubernetes really attacked that operations pain fundamentally, which is one reason why people saw so many advantages. And I think there's a little bit of that going on right now. These amazing code generation tools are helping people write code faster, but they're not yet, like, there isn't yet really things that are helping folks on the operations side. And companies, most teams, most orgs are not really yet practicing full continuous deployment.
Right.
So if you have made the investments in fully automating your test and deployment cycles, you can write code and you can run it into your pipelines, and you can, with confidence, know that it's not going to break things on the way to production, and you don't have human beings touching it, then the generative AI tools give you a lot of advantages, right? Because you can go fast and you can get all that stuff to production in a reliable way. But if you haven't actually invested in all of the tooling and approaches, which are sort of wrapped up in the 12-factor approach and sort of wrapped up in the like cloud native approaches, but if you haven't like fully automated your approach all the way to production, you can generate a lot more code, but you can't reliably actually get it to production. And so like you get backlogged. And one of the things that I'm super enthusiastic about here for the Heroku business over the next few years is that's a place we really help customers with. And so like we sort of help with the, eat your vegetables, take your vitamins, do your exercise part of the software lifecycle, so that you can actually take advantage of all of this like new productivity tools that are in the development space. But it's a tough chasm to cross to get from being more human-based to being like more fully automated. And I don't know, if you can't get across that chasm, it's going to be pretty tough.
That's a challenge for operations teams, you think?
Yeah, it's a big challenge. And I think the other interesting thing is that I find this, I'm a very rusty programmer, right? Like I'm primarily have a management job. I came up through the software engineering ranks, and it's just really amazing to me how useful the tools are for someone who's rusty or someone who's new to produce all this code. But then you still need all of the help to do the deployments and the testing, getting all the stuff to production. And so I think opinionated systems like Heroku are going to see a lot of growth here over the next 5 years as all of these generative tools get better and better and better. I mean, they're already amazingly good, but they're going to keep getting better and better at generating code. Those teams need the help.
So I guess my last question is like, how are you going to make it better for Heroku users going forward? What are some of the kind of things that you really want to build?
Well, I think some of it is just the basic heavy lifting of like bigger databases, bigger dynos, bigger all of these things. We definitely, like, one of the things we have coming out is Solomon said this at KubeCon. It was such a great line about all apps are AI apps. I think that's true. And so one of the things we're doing is we're working on like buildpacks support and AI dynos and all the things that if you assume, I think he's right, that that's the case, then there's a lot of things we can do to help there.
What's an AI dyno?
A dyno that has a GPU or some other kind of accelerator attached to it, so that you can run that piece of the code that much faster. So yeah, and I think we're super excited about what the stuff that we're doing with Hotel and additional observability. So more and bigger, I think is really our path at the moment.
Well, I'll have to look more into Hotel.
Yeah, that could be another thing. I think this is a little bit like the whole observability world has been standardizing as well. So Hotel is the OCI of the observability world. So it's kind of the next phase of standardization.
Well, Bob, thanks a lot for taking this time today. It's been nice to chat about the new Heroku, really, or the Heroku continued, maybe is
exactly. All right,
and we'll look forward to keeping in touch and seeing you at KubeCon.
Great, yes, indeed. See you there. Thank you so much.
Thanks. If you like this video, please give us a thumbs up. And if you'd like to see more videos like this, you can always subscribe to our YouTube channel. We're on all the major social media platforms. You can always find us at thenewstack.io. We hope to see you soon.